Well, good afternoon and welcome to the 2023 WEP Alumni Lecture Series. Hello, friends who are walking in just now. It's so lovely to see you all. I feel as though we're talking to a very empty auditorium. However, for the benefit of our 8 illustrious alumni presenters who are here today, I want to assure you that we're also live streaming, and I know in my heart that there are thousands of people all over the kingdom and all over KAUST and perhaps all over the world who are watching here now. So hello to all of you who are virtually connected with us this afternoon. For those of you who are in the audience, you might laugh when I say welcome to what is our largest ever alumni lecture series. Now, you might not know because the audience in the auditorium looks small, but this is our largest alumni lecture series because we have 8 fabulous alumni who are presenting this afternoon. And when my boss said, how did we end up with 8 presenters? We usually have 4 or 5. It is because our alumni community has grown and because I love all of our alumni, and it is very hard to determine from proposals and from the work our alumni do who to invite back to this very important event. The other thing that happened was that the alumni who were invited all said yes, and that is the first time in my 6 WEPs that has ever happened. And also, you all turned up, so thank you for that. So this afternoon, over the next couple of hours, you are going to hear from 8 alumni. And these alumni span all of the years we've had graduation at KAUST. So we have 3 founding class alumni. We have an alumna who just graduated in 2022. And then we've got alumni from all of our years in between. They're all going to introduce themselves and talk about their KAUST journeys and their professional careers. We have Seba Nadeef, we have Michael Margineau, we have Eman Al Hajji, Li, Justine Braguy, Ali Al-dawood, Jian and Mohammed Felamban. So without further ado, I'd like to introduce our first presenter, who is Seba Nadeef, to kickstart what is our largest alumni lecture series. Enjoy.
Good afternoon, everyone. Thank you very much for coming, and thank you for whoever is watching around the world. Thank you, Leah, for the kind introduction. It's my pleasure to stand here today and talk about my journey at KAUST and after KAUST. I meant to have this presentation as an inspiring presentation for the young students who joined KAUST recently and for the young students who came as visitors to KAUST for the first time also. And I hope that they get inspired by my journey more than the outcome of this journey because they need it. My name is Seba Nadeef, and currently I'm working as senior scientist at King Faisal Specialist Hospital in Riyadh, and I'm affiliated to MIT at Boston. So let me start by prior to joining KAUST. Well, I came from Taif, which is a small city on the mountain where I have studied biotechnology in Arabic. My English was super bad. And after that, there was a young institute called KAUST by that time, and I have decided to apply. And when I applied, I remember in the interview, I was impressed that how come I'm going to join KAUST and my English was super bad, but my grades were very high. Then KAUST offered for me a great support to travel all the world and have my first internship in the state as a female for the first time to be at George Washington University. And after that, I got a full PhD scholarship to start my PhD at KAUST in a gifted program that it's in partnership between KAUST and UC Irvine at California. And from there, I start working in a topic that's called epigenetic. And I'm sure that the majority does not know what epigenetic is. But briefly, if you ever ask yourself the question, what distinguishes 2 twins if they have identical genetic background? They are coming from the same mother and the same father. Then how they become different over time? Well, epigenetic explains this phenomena because we have modifiers that changing during our lifetime in response to our environmental factors. And this kind of response change our phenotype. And that's how the twins behave differently from each other, although they share the same mother genetic background and the same father genetic background. What is the importance of this mechanism is that they turn your genes to be on or off during your lifetime. And what we have done is that we published great work with our collaborator at the state, is that we found if we expose the mice to different high-fat diet, the food that contains a lot of fat, all your program or your genetic program is reprogrammed to new genes that some of them were on and they turn to be off, or some were off and they turn to be on in different tissues. And also this affects your metabolites. And this effect leads to a different phenotype that was observed in the mice. And the same thing is happening to our body as a human being. And after this successful journey, I had the opportunity to travel the world and talk about my great work. And I also gained some skills in order how to present. I participated in all the courses that KAUST, in most of the courses that KAUST offered, the entrepreneurship courses, the STEAM challenges, and TikTok in order to improve my presentation skills and or how also to deliver the work that I have been doing to different audience. And by 2019, I graduated, and it was one of the most happiest moments in my life. I graduated in 2019, but actually I left KAUST in the most challenging time of the year, which is 2020, where we have the pandemic. Most of the applications, the job applications, are stopped or going to be resumed after, a lot of rejections. But I was lucky that I applied to a fellowship that's called Ibn Khaldun Fellowship to support young Saudi women who earned PhD. And it's a very competitive fellowship where they select top 5 candidates. And this fellowship allows you to go to MIT in Boston to stay for 1 year. And you have the right to choose any lab if you are a good fit, and you wait for the acceptance of the supervisor of that lab to be part of the team. Then, back at MIT, I remember I attended 2 talks to KAUST where I have found that they invited a pioneer in the field of vaccines, because I wanted to move to translational science. And they invited Professor Robert Langer 2 times at KAUST in the WEP of 2020 and also in one of the entrepreneurship courses. And then when I listened to his great talk, I immediately jumped and I wanted to know, what is he doing? Well, they call him the Edison of medicine because he was recognized for his great work in vaccine development and drug development. And not only that, he's innovative. He knows how to transfer the bench work to the market and have a startup company. Well, he's basically got licensed or pre-licensed more than 350 companies in the field of pharmaceuticals and chemical biotechnology. And this journey looks great, but he was rejected at his early career more than once. And that's why I was inspired, because now he makes great collaboration in the field of industry and academia, where most of the students are struggling where to go, industry versus academia. And this for me was inspiring. But when I joined, I was shocked. What am I going to do in his group? Because they have a lot of chemical engineers, they have a lot of chemists who know how to deal with fabrications, but few who does biology. And I came with a pure biology background, so I was thinking, what am I going to do in his group? They are focusing at that time on different platforms to improve COVID-19 vaccines. He's the co-founder of Moderna. He's the academic co-founder of Moderna, where basically they are using the nucleic acid as a platform for vaccines like RNA and DNA. But we have other platforms like live attenuated viruses or inactivated viruses, or the platform where we use viral vectors to be injected to deliver the vaccine. So let me take you briefly to the research they have been doing, because this is a young project that it's reaching a patent level. So where we basically using nanomaterials, because now they have been well characterized in the market to be used as a carrier for vaccine, where we have used S protein, which is the antigen that it's well known for structural SARS-CoV-2. And in our system, in the system they have designed, they used gardicumab on the top, which is an adjuvant that enhances the humoral response and activate the antigen presenting cells in your dendritic cells. And they have used that in a nanocarrier platform, which contains the ZIF, the zeolitic framework 8, as a platform in nanomedicine that contains ions. And after that, they load these in microneedles and they inject you. And more importantly, not only the platform, we need to know when it's injected how the release is happening in our body. Is it safe? Is it toxic? So after trying a couple of doses, they have found if you can check in column 5 after 5 weeks, after using our this new platform, they have better response when they have did antibody titration. Antibody titration is an assay that tells you about the efficacy of your vaccine, how much antibody you get in your blood. So when they have tried this new model compared to the model that does not contain the ZIF8, we found in column 5, in the column in the middle after 5 weeks, we have a very good response, which means we are reaching what we are hypothesizing that this could be a new platform. So when I joined the lab, I wanted to investigate more than antibody titration. How can we understand more this vaccine or this platform in terms of immune response, toxicity, apoptosis in the cell? So I have introduced to them for the first time how to use sequencing techniques. And don't get shocked by the bars. What I want to deliver from this information is that when I introduced sequencing technique in the lab for the first time, it helped them to understand how can this platform be more specific to SARS-CoV-2 vaccine and how which immune response we can investigate more, if it's adaptive humoral immune response, and also the toxicity of the platform, which pathway we should focus at. So when I introduced this sequencing technique, we were successfully able to find that we have a better delivery of that S protein to the dendritic cells, and we have efficient activation of the T cells, which means our platform is functional, and also we have efficient immune response towards SARS-CoV-2. And why we are doing that? If you are asking the question, we have already Moderna and Pfizer in the market. Why we are exploring also different platforms? Because first, we need also to improve the stability. This is stable under different thermal conditions. And also, we are targeting low-income countries who cannot offer the standard vaccinations that we are taking now and those days. And also, you know, we want to improve the production of these vaccines. When we have an infection time, we want to speed the process. So this is briefly what we have been doing there, and it's a very interesting project. And after that, as you can see, I was exposed to different backgrounds, jumping from basic science to vaccines. And I thought about how if we combine all this, the three of them, genetic, vaccines, and epigenetics, to help the Saudi population upon my return. After that, I got accepted to be a senior scientist at King Faisal Specialist Hospital at Riyadh to work in their translational genetics department, and this to serve and help the goals of 2030 in the field of medicine and pharmaceutical companies to be achieved. If you ask yourself, what is personalized medicine? You know that each one of us has a unique genetic makeup. So personalized medicine will help us to jump from traditional medicine to design the medicine that fits your case, that it's suitable for your condition. But prior to that, we need to understand how to prevent the disease. And if we prevent the disease, we will also improve how do we diagnose the disease, improve the mechanism by which disease is occurring in our society. And all this will help us to achieve the goal of 2030, where we have aimed to be comprehensive and effective in the health system. So what we basically doing in the hospital is we have our unique population, where we have consanguinity marriage and marriage between relatives as a fundamental thing in our society, which could be a reason for having genetic diseases occur only especially in our population. So there are diseases that it's rare in the other world, but it's common in our population, and the frequency is very high. So we need to understand the genetic cause of that, and this will help us for the long-term future to deal with pharmaceutical companies to design products that it's only targeting genetic diseases in the Saudi population. So you think that this journey was very straightforward. By the time I have done everything, I struggled a lot, I failed a lot. The number of the rejections was more than the acceptance, and failure was more than success. But at the end, I gained what I was looking for, and I collected the fruits of my journey. And during my time at Boston, Cell Trends, which is a very high reputation journal, asked to write about my journey and how to switch in an environment that combine industry and academia. So I know that we have a young generation listening to this talk, hoping to get inspired. So what I want to say, the edge of in each student life is to decide industry versus academia, which is a very challenging question that cannot be answered at your early journey. What I want to share with you is a few points that it's fundamental whether you decide it's the industry or academia. You need to have a good mentor, whether it's academic or industrial journey. If you are aiming to go to the industry, he will support you to have internship in companies. Or if you want to go to universities, who will support you to be in that career path. Be successful on small things before the big picture. Some people, they get lost thinking about the big picture at the end, but they lose how to achieve the small things at the end. Brand yourself and never underestimate your capabilities. You are doing good. You are at KAUST, so know well how to brand yourself to companies or industries or people around you. And whether you decide to go to industry or academia, dedication and networking matters, even if you have zero experience. This matters in order to help you to be successful in your next career or in your next decision. And mentioning that, during my time at KAUST, I joined the entrepreneurship courses and the TED Talks and all these team challenges, not because I want to show that I have done that. When I joined Robert Langer Lab, they are transferring every project to the market, and they are building startup companies. When I joined, I did not know what is prototyping or how to pitch your presentation in 2 minutes, or what is the technology transfer office. But you are at KAUST, you have all the resources just across. Go there, participate, and get inspired. This will help you to figure out what do you want in your future. And even if you do everything, but you get rejected or you fail, don't forget your worth. Maybe it's related to your incompatibility, but you're worth a lot, so don't forget that. And during this journey, be happy and try to enjoy as much as you can. And since it's my first time standing here as a graduate, I would like to thank KAUST for giving me the opportunity to fly. And without KAUST, I might not be able to achieve what I have achieved today. And I summarized in this slide the beautiful pictures and the moments I have lived during this journey. And the one that is close to my heart is the one with President Tony Chan on the top, because he's a very humble and kind person that you can take selfie with him just around if he's there. And don't forget to share this in the web pages and social media. Thank you very much. Do we have any questions? Maybe online. Yes, thank you very much for your time.
Assalamu alaikum and good afternoon. I'm Michael Margineau, master's and PhD graduate in bioscience, originally from Romania, and I'm very honored and happy to be here today to share with you the story of my journey after graduating from KAUST in 2019. It is a journey that was inspired by the commencement ceremony that I attended in 2015 as a master's graduate, and in particular by the words of former President Jean-Luc Chameau and of commencement speaker Ms. Lumna Olayan, who encouraged us, KAUST graduates coming from many different countries all over the world, to also make a contribution in our home countries and benefit all the people of the world. This journey took me back to Romania and my home city Timișoara, which is located in the western area, and which this year is one of the 3 cities named the European Capital of Culture. While at KAUST, I was pursuing a study degree track in molecular and cell biology, and my master research focused on cancer nanotechnology, while my PhD focused on molecular neuroscience, and in particular, brain energy metabolism. In Timisoara, I took the challenge of exploring a novel research field in a newly founded research center, and I was tackling a major public health problem in the country affecting more than 500,000 people, which is allergy to ambrosia pollen. This immersed me into a translational medical research project with the aim to develop novel peptide-based immunotherapies that will aim to prevent the binding of an allergenic protein depicted here in yellow with IgE antibodies depicted in red. This is what really triggers the allergic reaction and the allergic symptoms. While this immersion into medical research was a new and challenging experience, in parallel, I've also started teaching in the medical school, and as a lecturer in human physiology, I had the challenge of starting to teach during the pandemic when teaching was done mostly online, which pushed me a bit to the edge, I would say, to adapt to this type of teaching style, and also to learn and teach about human physiology, the physiology of the whole human body, and the fine balance between health and disease. Considering that I was coming from a cellular-based background, this was indeed quite a challenge. But a very rewarding experience that has inspired me further. By interacting with young students in the medical school, as well as through outreach events at our research center, I was really inspired by the youth, passionate to learn more about biomedical research and interested to get exposure to the field. So together with two school friends, we have set up a mentoring platform dedicated to young students in high school and different stages of their career that enables them to find mentors in Romania and around the world pursuing research in biosciences and medicine. We have also launched an NGO that was enabling the organization of different competitions for students, which were mainly ideation competitions, stimulating them to be creative and envision future developments in biosciences and medicine. BioMentor Hub inspired me further, and in 2020, together with a team of 9 other young scientists from 7 countries, we have won the Lindau Science-a-thon, a competition organized by the Lindau Nobel Laureate Meetings Foundation. And as an alumnus of this meeting, I was able to propose an idea for a mentoring platform for this community. This was only possible because I attended this meeting with the support from KAUST back in 2018 with 2 other wonderful colleagues who were studying at that time here. So the experience with the Lindau Mentoring Hub brought me and another colleague for a second time to Lindau just last year, which is quite amazing considering that normally you'll get to go there a second time if you win the Nobel Prize or if you are invited as a special guest. So it has been a truly amazing experience. Now you might think that, well, this is the end of a happy home return journey. However, it's not the case. While I was back home, I was still searching for the research area that I felt will motivate me to pursue a long-term scientific career. And this inspiration came, I would say, unexpectedly while I was attending a very nice practical course in neurosciences in Bordeaux, when I've heard for the first time about the emerging field of cancer neuroscience, which is a very exciting area looking at the interaction between the nervous system and cancer development. In 2019, it was discovered for the first time that healthy neurons form synapses with glioma cancer cells, and this opened up a whole new field of study that is now looking at different angles at the interaction between the nervous system and cancer. So for me, it was an eureka moment, and I felt like I was, going to be part of the NASA team that landed the first man on the moon. I was really, really excited. And this excitement and motivation brought me back outside Romania. So in October last year, I've moved to the Francis Crick Institute in London, where I'm currently a postdoctoral training fellow in the Cancer Neuroscience Laboratory headed by Dr. Lian Li. There are, I would say, less than 20 groups now around the world working specifically on this topic, and I feel very privileged to be there. And this wouldn't have been possible without the continuous encouragement and mentorship from my PhD advisor, Professor Pierre Magistretti. At the Francis Crick Institute, currently I'm working on one of the most aggressive types of cancer, which is small cell lung cancer, a very, I would say, aggressive type of tumor that leaves patients with relatively low chances of living beyond 5 years. So the Francis Crick Institute is a new environment that I'm adapting to, like I had to adapt back home in Romania. It's a wonderful institute that was set up 5 years ago, and it is a unique partnership between 3 major universities in London, King's Imperial, UCL, and 3 other organizations supporting medical research. So I feel that now I'm pursuing an exciting research project in a very exciting research area. But what will be the next step in my career journey? Well, I cannot say with certainty what it will be. And many times we might think, well, what will be next, or what will be the next plan in our life and in our career? And when this comes to my mind, I remember this very nice quote from Dr. Chamon, who was saying to not concern ourselves with planning the future so much. Of course, we should have an idea what we would like to do and what we like. But what we should really focus on is pursuing excellence at each stage of our career, wherever we go. And when we strive to do this, the opportunities will follow us. I truly believe that with the KAUST spirit in our hearts, with the experience we've got here, with all what we have learned, we have everything we need to make a contribution wherever we go in the world and make the world a better place. So I really encourage you to be bold, to be courageous, and to follow your passion and find what motivates you the most and what drives you the most in your career, be it in the scientific field or in a different area. With this, I would like to thank you very much and wish you Atamana lakum al-najah. Much success in all your endeavors. Thank you very much. Yeah, in case there are any questions, you're more than welcome to ask. Also, you can reach me anytime through email or on LinkedIn. All right, thank you once again.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, ladies and gentlemen. Today, my name is Eman Al Hajji, and today I'll give you some snaps of my story. I'm going to talk about creating my own edge. I was a little girl who bothered her father by asking him so many why questions. Seeking the divine truth, I found 2 ways for the truth: the internal wisdom of knowing right and wrong, and the clearest way, which is the scientific way. I moved since a young age to understand the natural beauty of the world and the unseen order and seek harmony both in the national world and with the human connections. Nonetheless, the path was not easy. I found myself at the age of 17 on the bed of the hospital suffering from the C-section surgery. I had my first little baby at the age of 17, and I'm glad we had 9 months of pregnancy, although that was not enough to prepare. It was a great experience, full of challenges. I knew at that time I was just in my second semester of high school, and was amazing is the determination, because I was very determined to achieve very high grades, because I wanted to go to explore more and pursue my career and my future. So I remember I studied really hard. I asked my friends, my family. They were very supportive. My husband, my mom, and my dad. And actually, for the first time ever, I got 100% in high school. So that was a great achievement. Odds were there. After that, I received a call from actually KAUST. I was really surprised when they called me back in 2012, and they asked, are you interested to go study abroad in the US? And I told them, who are you? They said, we're King Abdullah University of Science and Technology. I told them, I've never heard of you. Where are you located? They said, we are in the west of Saudi Arabia and near Jiande. And I said, okay, that really exists. And they told me all about the amazing things at KAUST. It's edge on research, it's beautiful community, it's this very prestigious scholarship. And because at that time, I think as many of you, when you had really excellent grades, your mom and dad either want you to be a doctor or an engineer, right? And at that time, I've never thought of studying abroad. I said, okay, I'm gonna do it home here. And I thought KFUBM at that time had a female section, or like we could study engineering, but I was shocked that was only for male. And this KAUST opportunity was a gift from God. He said, okay, now I'll make my parents proud, I'll pursue what I really enjoy, because I'm a very passionate person. I love science, I love chemistry, physics, and I love engineering. So that was a great journey. Back in 2012, I head to the US with an 8-month-old baby and my husband. The road was not easy. It took me a 6-year of roller coaster until I graduated from NC State, North Carolina State University. And again, I was against odds. I got a full brilliant GPA, 4 out of 4, with a baby. And yes, that took a lot of efforts, a lot of family sacrifices, a lot of support from my biggest supporter, my husband, Hamad Al-Khamis. And then that was back in 2018. After that, I was entirely ready to go back to KAUST. During that period of time, I equipped myself with all enrichment opportunities, from doing research internships to being part of the National Academy of Engineering to University Scholars Program and so on. Then I came to KAUST in August 2018. I started embarking my own PhD journey, trying to innovate nanocarbon material by laser irradiation for advanced research, rechargeable batteries. As all of you know, PhD is not easy. There are ups and downs. There are so many failures and successes. And I'm glad I did my PhD along with my master's in 4 years because of the support, immense support of my BI. Thanks, Professor Hassam Sharif. It was, of course, connected to living this in harmony, because through powering the future, I thought that we also need to protect our environment, empower and cultivate human potentials at the same time. And I thought that was a niche area to do good for humanity and where I could solve a problem. Nonetheless, during my PhD time, I felt there was a gap between my own bubble and my world in the academic world and the outside world. I was very laser focused at the beginning on my research, but I thought there must be something that I could do more to create impact. And I thought the ideas that we generate in the lab could not just like publishing papers or increasing my H-index and journals. We should really, when we have knowledge, we should truly act on it for the sake of and the betterment of humanity. So because I saw this gap between academia, industry, government, and community, I thought to start with other colleagues, the KAUST Students for Sustainability, starting from within, outward with small, smart steps. So back in 2019, we formed this very diverse people from nationalities. Most of us did not know each other before. And you will hear later from Justine as well, who was part of the founding members. We gathered very multi-passionate, very determined to create this, which became later on the most active student group on campus. And we had the immense support from Dr. Anna and other professors, Professor Thya here, after connecting the dots again. During that semester, I had my first time to take electives, and I took energy and environment and economy, and the other one was sustainable engineering. And that ignited me, like, now I have this knowledge, which is like heavy load, and I wanted to act on it. I cannot just sit in the classrooms hearing all about the global challenges in terms of climate change, biodiversity laws, overpopulation, and just live in this place full of resources and do nothing. So from there, we had a huge success in terms of compound effect. You've seen these buses around. This is part one of our initiatives. We had several workshops, week of awarenesses, programs. If you go to Tamimi now, there is no plastic over the counter. Hopefully that goes over with the support of the Office of Sustainability and other departments here. We all own sustainability. I also initiated the Sustainability Seminar Series, which has been going every semester. We have so many distinguished speakers, including the president, provost, and other amazing people. Along that, we did CUHK and COP tournaments and other amazing efforts. For this, in the G20, I want you to look into William, world leader in sustainable innovation, William Mcdonough. He's a distinguished professor now at KAUST, and during that time, I invested in myself. I made this trip to go to the G20 workshop, and that was the first time I met him, which I want to show you a small case of the power of networking. Later on, at that time, I was not afraid to go and talk to him. He was the keynote speaker in this giant meeting full of, high caliber people. And I was the little one coming from university. And I was not afraid to go and ask him questions, connect. And we had a great chemistry during that time. That was only in my second year of PhD. Moving forward, I was delighted to be selected a young change maker in this summit in Switzerland. We met with ministers, professors, and people from all around Europe and the Middle Eastern region. After seeing the huge potential of youth in making impact and uniting our voices to create a better world, I thought, what about nationally? Do we have an existing kind of initiative that unites our voices? And when I looked around, I saw nothing in the kingdom. So we started Saudi Youth for Sustainability, which we launched back in November 21st. So it's almost 1 year and 2 months, and it's a youth-led national organization that aims to connect and empower young leaders to drive positive changes on sustainable future across the kingdom. So today we have more than 1,200 members, both impact supporters and young change makers from all around the kingdom, from rural areas, from villages, from big cities, which is really amazing. So here is our logo. We know that true sustainability is within the intersection of economy, society, and biosphere. And that's why I'm so attached to this framework, because it gives a clear way on how to live in harmony with your existing, with your passion and your contribution in the world. So yellow is for youth and community, blue is for the Saudi economy, and green is for the environment. We have 4 missions to create seeds of sustainability organizations in the kingdom and Saudi universities and empower youth to lead bottom-up changes. We wanted to promote national and international networking of youth, advance and disseminate best practices, and foster knowledge sharing. So far we have so many programs, including Young Leaders, the annual conference, Sustainability Creativity Workshop, Active Citizen, Energy Voice, as well as special talks and sustainable oral health care. I'd love to show you a little bit short video of our last conference. It was done by youth for youth. We also had several amazing opportunities following that. We got recognized nationally. We got invited to the first nonprofit national meeting, where we see here the Minister of Commerce along with the princess. We also went to Sharm el-Sheikh for COP 28, and we had some 28 hopefully soon. We had several talks in FII and other interviews here as well, and as well as the Saudi Green Initiative. I would love to say that now I graduated back in, I defended my PhD in September last year, and today I'm a research specialist, and finally I found my dream job. I just started, yes, and I'm sure that it's a beginning, and I'm so grateful for KAUST for building me. I always tell people that I feel truly I'm a child of KAUST for supporting me to this entire journey. And now, yes, I'm a research specialist with the world leader, Professor William Mcdonough, and I cannot wait to give back to the world. And would love to end with the 3 golden rules for life. First, always remember to expand your horizon, to see the hidden beauty of this marvelous world. Tune into your amazing self to find your own voice, to find your own edge. Wonder and do better. Welcome challenges along the way, embrace them. And always, with uncertainties, maybe high risks, but high rewards. You only have one life to live, so live it fully. Keep fulfilling the four L's every single day: to live, to love, to learn, and to leave a legacy. And I would love to thank you and welcome your questions. Thanks. If not, then we go to the next speaker.
Okay, hello everyone, good afternoon. I'm Yu Li. I'm currently an assistant professor in the Chinese University of Hong Kong. I studied at KAUST from 2015 to 2020. I obtained my master's degree in 2016 and a PhD in 2020, both majoring in computer science. First of all, I'd thanks a lot to the WEP organizer, especially Lee and Warden, for bringing me back here. Actually, it's not an easy journey. My Saudi visa was rejected 3 times, an even larger number than my US visa applications. And also thanks to Jay, Lee, and Warden, we finally made it. A few years ago, I was a student like you, sitting downstairs, listening to the speakers. Now, I became a speaker here, standing on the stage, and giving a presentation to you. I'd like to talk about how I became you, and how eventually I became the current me. Back in 2014, I was a college student at University of Science and Technology of China. So that university has a kind of tradition. Roughly 35% of the students would study overseas, and most of them will go to the US. So at that time, like most students in that university, I thought my next destination will be somewhere in the US. But during the postgraduate program application period, for curiosity, I also applied for the, at that time, kind of mystery KAUST. Noticing my application, my PhD advisor, Professor Xin Gao, he called me overseas for more than 1 hour, persuading me to join his team. So eventually, I accepted the master to PhD offer. But honestly, before I came to KAUST, I thought of leaving KAUST with a master's degree and go to US after that. But after I really lived here and studied here for 1 year, I found that KAUST is really a great place to do research. And eventually, I decided to stay. In 2020, I graduated from KAUST with a PhD degree. During that time, despite the hiring freeze due to COVID, I was interviewed by several top universities globally for the faculty position, such as Georgia Tech, CUHK, TTIC, and some other universities. And also, I received the postdoc fellow offer from MIT. So eventually, I decided to take the offer from CUHK, being an assistant professor at the computer science and engineering department. So I essentially jump over the postdoc period. So 1 year later, the Forbes office contacted me. And in 2022, last year, I was listed in Forbes 30 under 30 Asia, considering my work in healthcare and science. Oh, by the way, I was young when I graduated from college. So I graduated from college when I was 20. I essentially received my PhD degree when I was 25. Essentially, before I came to KAUST, I was just an immature and unknown undergraduate student without too much academic training and feel uncertain of my future. But after I graduated from KAUST, I became a mature researcher, known by some people, and at least the people who know the least. You know. I'm the guy who experienced the change, and I like to attribute all the recognitions that I have received in the past 2 years to KAUST. So KAUST is an excellent platform on which we can achieve our academic ambition. So during my PhD study here, thanks to my supervisor's connections, I participated in around 30 projects, leading around 15 of them. Some works were published in very well-recognized journals like Nature Family journals. I received extensive training in almost all the aspects of bioinformatics, from sequence analysis to structure prediction, to functionalization, to disease diagnosis, to drug discovery, as well as drug resistance study. I handled almost all the data types you can think of, such as images, sequences, graphs, tabular data, and so on. Such extensive training greatly benefits my career development because I can recognize the promising projects to work on. I also benefited from the kind of collaborators inside KAUST. I collaborated with researchers from all the 3 divisions in KAUST, such as Professor Mo Li from BESE, Professor Shu Yusun from PSE, and all the other excellent researchers in our division, CMC. KAUST has a nice reputation worldwide, and thus I got a chance to collaborate with researchers globally, including people in the US, Hong Kong, mainland China, Europe, Japan, and so on. So I have extensively used the computational resources and the machines in KAUST, such as Shaheen-2, Ibex, Dragon, and also facilities in Colab, including the cryo-EM machine. I have also used the KAUST library resources extensively. So I'm the guy who's suggesting the library to subscribe to some very new journals, such as Natural Machine Intelligence and Natural Computational Science, which was just established a few years ago. I have benefited a lot from the graduate services. Before coming to KAUST, I was quite shy and even didn't know how to speak in public. I received help from the graduate service to improve my presentation skills, and also they helped me a lot in improving my CV and the application portfolio while I was looking for an academic job back in 2019. So I would say, without the connections and help from KAUST, I won't have achieved that much. So regarding the students who are still in KAUST, I have a few suggestions. Firstly, do communicate with your supervisor occasionally to make sure you two are on the same page so that he or she can help you identify the problems and help you improve yourself. Secondly, try to take full advantage of the connections and the potential collaborations set up in KAUST so that you can build up your brand and set up your reputation, which can help you attract more collaborations and more opportunities in the future. Also, KAUST has all the resources that a world-class university should have, such as the computational resources, world-class facilities, a rich library collection, and supportive people. So essentially now, I'm an assistant professor in another university, and I also visited MRT occasionally as a visiting assistant professor. In fact, I'm also going to visit MRT again during summer this year. So I can guarantee that KAUST has world-class facilities regarding research compared to all the other top universities. So please do use them. KAUST is a place with great work and life balance. While you're enjoying life here, don't forget to make full use of the world-class resources and opportunities here. So you will appreciate it, and you will appreciate your efforts after you leave KAUST in the future, hopefully as a cutting-edge researcher. Thank you very much for your attention, and I would say thank you, KAUST. Yeah, do you have any questions? No? Great.
Hi, everyone. So thanks for inviting me today. This is me. I'm Justine, alumni in plant science as a PhD student, and I graduated in 2021. I'm currently the CEO of Thya Technology, a newly formed startup in KAUST, and we are providing computer vision as a service, AI-based. So in that talk, I wanted to talk first a little bit about my experience as an academic, and then as well how we translated the idea of a PhD project into a startup. So I started my academic journey as a bachelor student in chemistry, physics, and mathematics. And you can think like, chemistry, because I wanted to become a chemist when I was younger. Now a plant scientist PhD, something went wrong in between. Yes, I realized that chemistry was not really what I was expecting, and maybe not as challenging as I thought it would be, or at least interesting for me. So I decided to shift in my master into biotechnology with a major in synthetic biology. But then I was thinking that I'm just getting to learn a little bit more about biology, didn't do biology for a long time. I was not really feeling ready to move forward into industry, so I decided to extend my academic studies and pursue a PhD in plant science here at KAUST, as I also had this great opportunity. And during the last year of my PhD, I had the chance to somehow come into a startup that was doing computer vision and machine learning, and I am now the CEO of it. So when you look at all these highlighted fields, chemistry, physics, mathematics, biotech, plant science, computer vision, and machine learning, this is a lot. And we can all think maybe this is even too much. But actually, I thought that this whole experience has been very interesting. And from this, I want to share with you 3 points. So the first one that I learned over my very little experience is that, of course, everyone knows that, and it's not a groundbreaking news, but everything can be learned with time. And that I feel during your study, more specifically, is the perfect time to try it out and take the leap and try to learn something new, because this is a study time. Then you also need to know how to tell your story. Maybe some of you here already thought oh my God, so many different fields, you might feel lost. Actually, the way you see yourself and the way you see your progress also does matter, and the way you present yourself to people is also very important. So for instance, in my case, things that chemistry was not really made for me, then biotechnology was actually great, because it was a mix of chemistry, physics, mathematics, plus biology. And then that technique that I learned in biotechnology, which is more creating tools for biology, was very valuable for my PhD in plant science. And finally, all of those topics were great. Now, in the startup and computer vision and machine learning, of course, I'm not doing any coding. I have a great tech team that is handling all of this. But to talk to customers and find application, I understand everybody, and I can talk with everyone. The last one, which was as you can imagine, because I was changing fields for every step of the way in my studies, I never really felt good enough. And so imposter syndrome was always with me the whole time, because I was lacking of representation. And I actually got only one representation, which I feel was still very important. It was the jump between my bachelor and my master, when I decided to do biotechnology. And I applied at the school, and they sent me an email telling me, you're applying to a biotechnology school, you need to know biology, and you also need to learn German, because it was a tri-national school. And I was like, okay, do you have anyone else in your team in your students, that already did the same thing that I did, that is coming from chemistry, physics, and mathematics, and that is actually making it through? And they told me, yes, there is one lady, and she's going to graduate next year. And I was like, well, then if she can do it, I can do it too. And that's a bit what I want to also share with you, that for me, it was just needing this one person who showed me that it was possible, that then motivated me to take the change and make the leap, and basically test something new. The second transition that I wanted to talk about was from PhD to startup, and how the PhD project, one of my PhD projects, was serving as a foundation for my startup. So how to make a startup from a research idea, basically? Well, one of the things that I was very interested in my whole study was optimization. There are tasks that I hate doing, and when I hate doing them, either I find someone to do them for me, or I find something to do it for me. And that's the second point that basically I used during the startup and my PhD. So basically, I've been doing plant science here at KAUST with the bioactive lab led by Professor Salim Al-Babili, and we are studying in some of the research is a parasitic plant called Striga ermontica that is parasitizing different types of crops, including rice, and that was one of my major crops. And basically, in that research workflow, what we are using is Striga seeds. We apply chemicals, and then we see if they are inhibiting or boosting the germination of the seeds. We take pictures with a microscope, and then we have plenty of pictures to analyze. That they look like this. Lots of tiny seeds, between 50 and 100 seeds per image. We have at least 6 disks or 6 images per condition, and then you have multiple conditions per experiment. So you can imagine that one experiment, a couple of hundreds of pictures, take you a couple of hours or days, takes a lot of time for just counting manually. So the idea here, it was that create basically an AI-based detection model that will help me to count germinated and non-germinated seeds. So what we did is teaching the algorithm what is a non-germinated seed, which is basically just a seed coat, and a germinated seed that is basically a seed coat plus a radicle, which is a baby root, to kind of tackle this problem of time-consuming task. So once the counting was automated by the algorithm, we passed from manual analysis that can take up to a week down to 2 hours in automated manner. And our algorithm was 93.5% accurate. If you compare to human error, it's approximately 95% at the beginning, and then with time it decreases by the more image you have, the more tired you get. And that research has been published in Plant Physiology in 2021. But it was a great discovery. It made me win a lot of time. I had my free weekend, and everything was great. However, the technology was only available for Striga ermontica, and it was only also available through a software that sometimes was a little bit more difficult to install into Linux or Mac or Windows. So the idea of the startup came to generalize that idea, to generalize not only for Striga ermontica, but for anything that is on pictures, and to not have to depend on a software, but that the technology can be used anywhere. And this is where we created the startup that is called Thya technology, and it's very new. We basically got incorporated last September, and we are just at the beginning of the journey. We started actually that journey through the Takadam Accelerator program here at KAUST, and we were among the winners of last year in 2022, sorry. And we were the only startup from KAUST who actually won. And what was great is that that accelerator program gave us a prize, like with money. So it was already a good start as a startup. And also the KAUST Research Translation Fund was also very supportive to help us in the transition from the research down to the startup. So we were like already quite generously financed as a first step of the startup, which was great to push the tech. And with that push, we were able to create this online platform where basically our users just have to upload images on the platform, then annotate, so basically tagging the different objects. Here you have palm trees, and so you have to put a square between, around each palm trees. Then you just have to click on a button, which is training the algorithm, and then you have your detection model ready to process multiple images that have never been seen before. It can give you then data that will tell you how many palm trees for each image there will be and where they are located as well. And this whole process doesn't require any code and can be done in a couple of hours down up to a day, depending on how many images you need to annotate at the beginning. And that application was also was already successful in application in KAUST because it's very useful, for instance, for research. We help automating the red blood cell counting here at KAUST for malaria studies, as well as doing some spine detection in neuron pictures. It can also be used for counting bacteria or fish identification, plant disease detection, and much more. So that's basically it for me. I hope that somehow it was insightful. And if you have any question, don't hesitate to contact me. This is my personal email address. And you can also, if you have any challenges that need to be automated in your own research, please feel free to drop an email or contact me on LinkedIn. I will be more than happy to answer you. Thank you.
I have a question, Justine.
Ooh, cool, yes. Unexpected.
First of all, I'd like to say congratulations on the startup. The idea is amazing, and I think it's gonna have a huge potential in research and even medical applications, even in healthcare. I wanted to ask you if you could give us more context about why you named your startup this name.
Sure. So Thya is a derivation of the Greek goddess of sight, Thea. But because we thought it was a little bit difficult to pronounce because it's like written T-H-E-I-A, and depending on the language, not everyone is pronouncing it the same way, we simplify it to Thya. But yes, Greek goddess of sight, helping for computer vision with a bit of women empowerment. That's the idea behind.
Okay.
Yeah.
Wonderful.
Thanks for your question. Any other questions? I was not expecting. No? Okay, thanks. Well, next speaker.
Through the lens of edge, I'm going to demonstrate to you how we can actually transform our ideas that we defended so well in our PhD and master thesis from, master's and PhD thesis into breakthrough and cutting-edge applications. Ladies and gentlemen, my name is Ali Al-dawood, a proud KAUST alumnus and currently working for EXPEC Advanced Research Center in Saudi Aramco in Dhahran. And it's really my pleasure to be here today and thankful to the KAUST alumni team for having me here 6 years after my graduation to come and speak about my research experience. 10 years ago, I was honored to be the commencement speaker of the class of 2011. And I very much remember what I said, which is my KAUST oath. I said, as messengers of KAUST, our responsibility now is to transfer the knowledge to the younger generation and provide solutions to the world problem, come up with great ideas to utilize natural, renewable resources for energy more efficiently, and to develop new theories in applied mathematics and computational and life sciences. Ladies and gentlemen, I'm going to tell you today that keeping that oath and working it so hard is quite challenging, because as with any other messenger throughout the history, the difficult part is not to convey the message to the people around you, but actually to make them believe in you. So let's start the journey of transforming my research into real-life applications. I tried to convey the message to my superior in Saudi Aramco that, the key to an accurate fracture diagnosis in the medical imaging, for example, is high-resolution X-ray of the bones. Similarly, in our oil and gas industry, we need an accurate imaging of these hydrocarbon traps, and we need to image them with high resolution to be able to extract oil and gas. Well, this is what I did in my KAUST days, which is the synthetic example in which I assumed an Earth model, and I want to image the boundaries between these layers, which we call the reflectivity image. For many decades, the image we used to get is what we see in the top right corner, which is this blurry depiction of the actual subsurface reflectivity. So this resembles me taking off my glasses, and all I can see is a blurry depiction of your faces. Well, now I don't know if you're happy about my presentation or not, so I need to go consult an optician that he will iteratively, which is this least square migration operation, try different lenses with different powers until he arrives to the right one that focuses the right image for me. And this is what we call the least squares migration image that you see on the bottom right corner. I carried that technology to my field example here in Saudi Aramco. And what you see on the left side is the blurry depiction of the subsurface reflectivity. And what you see on the right of this field data example is a highly resolved subsurface image that helps our interpreter make good prediction about the subsurface. Well, this is the second application that I try to convey the message of to my superior in Aramco, which is the application of sparsity promoting migration. As all of you have struggled through your PhD, I was struggling also to get a great idea. So I was digging deep in this geophysical literature, and then Professor Tariq Al-Khalifa told me, if you cannot find an idea because you're searching somewhere where it has been done already, so you better look at other disciplines. I was not aware of that at that time, and I kept digging in the same geophysics research. One of the guys, my friends, asked me once to come along with him to a EE seminar in KAUST. And I was like, you know, I'm not interested. But he said, oh, they have free pizzas. So I said, yeah, I'm interested in free pizzas. So I went there to eat some pizzas, and to my surprise, Professor Tariq al-Nafuri was presenting sparsity-promoting technologies. And I looked at the examples that he showed from his EE experience, and I was really interested in transferring that knowledge to our seismic problem. I took a course with him the next semester on this very topic that I then applied to this KAUST synthetic example. So going from the subsurface Earth model that I assumed, we showed how we can get the least square migrated image, top right corner, but then if you apply the sparsity promoting migration to sparsify that image, to suppress the artifacts, you can get an image that includes resemblance of what assumed to be the right Earth model. Well, I carried that over to my Aramco experience, and I applied it to a field data example from there. So what you see on the left is this adjoint operator or migration that we lived on in the 60s, 70s, and 80s. And then the least square migration is the middle panel. But then if you impose the sparsity promoting, you suppress a lot of artifacts, particularly in the shallow section, and you end up with a highly resolved image of the reservoir. Well, then a turning point in my career was when we envisioned a new technology called drill cam. We wanted to invest for a real-time system to monitor our drilling operation. Well, we all like sensors, particularly say in our cars, the blind spot technology, the 360 cameras, and all these new technologies in the cars that make our driving safe by minimizing the risk. Well, investing in a car might cost you about, what, $20,000? And if you want to go fancy, maybe a few hundreds of thousands of dollars. But here, we're talking about a drilling rig, which in land costs about tens of millions of dollars. And if you move to a marine case where you want to drill a rig, it might cost about $100 million. So we really need to monitor and put sensors there to monitor our drilling operation with quite accuracy. So what we envisioned is to populate the region around the drilling rig with lots and lots of receivers to capture the seismic signal. Coming from where? From a source that's active throughout the drilling, which is the drill bit transversing through the medium of the subsurface down to, say, 4 kilometers. So when I saw that, what we envisioned, I very much remember my KAUST days, which is chapter 10 of Jerry Schuster's book, The Stochastic Interferometry. And I get the same cartoon that shows the drill bit seismic that is there, which is a technology that was living in the 80s, but it never saw the light commercially. So we decided to move this, and I convinced my superior that we need to do this, and this is what we got by transforming what we envisioned to a real data applications. So what we see on the left panel is basically the wireless geophones in synchrony with the stop drive accelerometer and a downhole accelerometer. What we need to do is basically record this drilling of the vibration drilling bit all the time, at all instants while we are drilling, and make them talk to these wireless geophones to be able to extract some subsurface signal. Well, we populated the area with 2,500 receiver stations around the rig to capture this beautiful wave field coming out from the drilling operation. What I show here is basically a snapshot of the wave field. Through the rattling of the drill bit and the drill pipes, the seismic wave field basically travels to these receivers. And this is what we get as a snapshot. This resembles me throwing a rock in a pond, and this is the pattern you see with all these rippling rocks traveling to the side of, say, a swimming pool. Well, if it encounters any obstacles, these wave fronts is going to deform. And we will know that maybe we have cavities in the vicinity, and this is a very alarming signal to the crew that's actively drilling this particular well. Well, not only that, we managed to basically also process this data and clean it from the drill noise and come up with the signal that's coming directly from the drill bit, which if you see these ray paths that it travel, it resembles basically a hyperbolic move out that comes through these time series. And what we are trying to find is this very faint crescent. It's like looking at the crescent of the Eid on the very last night of Ramadan. So we found it at the end, and we managed to turn it for every drill bit position into a very useful information. And that is the time-depth relationship, which tells the interpreter or the geologist that we are transversing through a different media with different acoustic properties. So it's a beautiful application that's not commercially available, but now that I conveyed this message, policy has changed, and now we are working on a kit that does that automatically for every rig, hopefully in Saudi Arabia. The second one is the virtual source method. And if someone is speaking behind my back, all I can do is basically take my eyeball to the furthest point and hope that I can see who's basically coming behind me. But if we use multiple reflections, just like you do in your car, you can use the mirror to see the back of the car. And that's nothing but taking the eye into a virtual position, which is right at the mirror, to see the back of the car. And if you have two sets of car, like in a barber shop, you can utilize these multiple reflections to even see beyond sight. So now you can assess your haircut by having two sets of mirror, one in front of you and one on the back of your head. Well, I did that in my KAUST days, and this is what I defended in my thesis, because the basic image is to try to image energy that travels from the source on the surface, hits the reflection point in the subsurface before making the final journey to a receiver. But if you use this multiply energy, you can image beyond sight and have a further away point from the rig to image it. So you get a wider subsurface illumination. Not only that, you can create these virtual sources, which is a method we call the dual simultaneous acquisition. And this was my dream experiment to execute at Saudi Aramco. But it's highly costly because I need to insert two wells with sets of receivers and start shooting on the Earth's surface. Why? Because I want to move that source S that travels and hit the receiver A in the well number 1 before making the final journey to well number 2. If I have that, it's similar to what we saw with the car and the barber. I can lower that source and create a virtual source down at one of the well, which is the resultant of this operation. Why am I interested in that? Because a cross-well tomography is very wide in other fields, but there are seldom experiments that has been done in the oil and gas industry. Why? Because we need to instrument at least one of the well with physical sources. And if you tell your peer engineers that you want to ignite seismic sources down at one of the holes, I don't think this is what they will hear. All they hear is that we want to fire some explosives inside the well and listen on the other well. But if you have it as a virtual experiment, they might be very interested to have such experiments. And thankful to this distributed acoustic sensing or fiber optic technology, we can instrument these two wells with DAS cables, the one that we use for telecommunication to transmit the internet. and we can turn them into acoustic sensors. And these cables, they already exist in many of our wells at Saudi Aramco, because the engineers want to use them to measure temperature or pressure down at the reservoir level. And we can utilize them as sensing tool to record seismic wave fields. So this is a really dream experiment that saw the light after convincing my superior. So now we have, interestingly, an experiment that we successfully completed with 200 shots on the surface, and we listened to these two wells simultaneously. And what you see on the right panel is basically the seismic wave field that we recorded at these two wells. And this is the data that we will be processing for the next year or so. So my takeaway message today is that utilize your time in KAUST by solidifying your theoretical background, demonstrate with synthetic data examples the value of your PhD research, and then once you move to the industry or your startup companies or any discipline, for example, for me, it will be the oil and gas industry, try to create values out of your research and hand it to these proponents that you will be dealing with. Once you do that, you're going to turn it into business opportunities or even field trials like we show in this example. The final remark is I'd like to thank KAUST alumni team, the KAUST WEP organizers for having me here, inviting me here. It's quite emotional. I haven't been here for 6 years, and I want to tell KAUST, the building, the spine, the diner, the steps, that I miss you so much. Thank you, and have a good day.
Good afternoon, ladies and gentlemen. I'm very happy and excited to be back to KAUST again. I haven't been here for more than 8 years when I went back to China in 2014. So my topic today is a practical example of the environmental research to environmental protection industry. As you can see, my focus today is only on the technology side. And the technology is called the catalytic ozonation. So this is my short bio. I graduated from Zhejiang University in 2009 and got my master's degree from KAUST in 2011. And after that, I worked at King Abdullah Petroleum Studies and Research Center at Riyadh, and then worked at Environmental Technology Innovation Center of Jiande, which is located in Hangzhou, and where Hangzhou will hold the 2022 Asian Olympic Games this year. So invite all of you to come to Hangzhou if you have time. And then I start my own business and now work as the CEO of Hangzhou Butter Catalyst Company. And also, I'm very honored that to be one of the global change makers for 2012 KAUST, the award. So as we know that for the researchers, especially for the engineering-related researchers, generally we did such experiment in our daily life or daily experiment. And for my environmental research, we use the ozone reacting with catalyst to produce ROS, reactive oxygen species, to degrade the pollutants in wastewater or water. And then remove, which we call the COD, chemical oxygen demand, to have a better quality of the water. So in lab scale, usually we use the beakers and some cabinet, some oven, and these ultrasonic cleaners to produce the catalyst, and then use ICP and also other equipment to test the performance of catalyst. So after that, we will produce a lot of useful conclusions or
information. For example, we use the ESR, ICP, XPS, and so on to characterize the performance of catalyst, and then to propose a mechanism for the catalyst. For example, in my research, we found that the modification of catalyst can produce the, as you can see, the free radicals in our reactor, and those radicals can degrade the pollutants to have a better quality of the water. So after that, generally we will have papers. For the past, I think around 4 or 5 years, we have at least 7 papers which is related with the catalytic ozonation. Although it is not in Science or Nature, but quite good papers in the environmental engineering and science side. Some of them are in the applied catalyst B or Chemsphere, which is famous in our field. And sometimes we will release some patents. As this work is almost done in China, so all of those 14 patents in Chinese, I translated them a little bit. You can see some of them are related with the materials itself, the catalyst. Some of them are related with the equipment used for the catalytic ozonation. So most of the research work will be finished or end with those papers or patents, but that is not enough, especially for the engineering-oriented majors. So next, we will transfer those outcomes into the engineering projects. So the first step will be the pilot study. As we can see, the pilot study is defined as a small-scale test of methods or procedures that can be used to a larger scale. This is from the Dictionary of Epidemiology, and Wikipedia said that it is a preliminary study conducted to evaluate feasibility, duration, cost, adverse events, and finally, it is used for a full-scale research project. So you can see it is a robust bridge between the research and the real project. Oh, I would like to mention that the picture on your right side, it is a pilot scale experiment equipment for our catalytic ozonation. It is a cubic room, and every time we can put this into in the treatment plant to treat the wastewater to test the performance of our catalyst. And for my research, we have 2 kinds of product. One is the catalyst itself, and second is the set of equipment used for the treatment of water or wastewater or water. As you can see that for the catalyst itself, after we study the research since 2008, we got to know the mechanisms behind that, and then we built a plant to manufacture different kinds of catalyst. Currently, we have 3 kinds of catalyst, including carbon-based, aluminum-based, or ceramic-based. So each series of those catalysts can be used or applied for different quality of the water and to treat the wastewater or the drinking water. And the second product is a set of equipment for the water treatment. As you can see, the picture on the bottom, the right bottom, that is the equipment for the real project. So take the catalyst production or manufacture as an example. From the research to the manufacture of the catalyst, generally we have several things to do before to produce the catalyst. First, we should have to find a plant to produce catalyst. For the plant, we have to do the energy assessment, the environmental assessment, and the safety assessment. This is the regulation in China. Different regions or different countries have their own regulations for those things. In order that we will have a plant with high efficient in energy consumption, environmental friendly production procedure, as well as it is a safe project for the whole manufacture process. And then we have to plan to do the design of the plant and the design of the manufacture equipment. And after that, we need a team, not only the research team, but a team for the manufacture workers and a team for the applications and so on. So it is a team with different advantages from different people. And after that, we will have to establish a supply chain. For example, the materials, raw materials, the company for the raw materials or our client, something like that. So for my environmental technology, we have the first plant in 2015 in China at Hangzhou. And we have our first production line. It is small production line, only every day only produce around 3 cubic meters of the catalyst, but it is a very good start. And after that, in 2017, we have our new plant with the second production line. And during this time, every year we can produce 1,000 cubic meters catalyst. It can be used for about 5 to 10 engineering projects every year. And those are some examples that we have used our catalytic ozonation technology. As you can see, most of them are in Zhejiang province, which is where I currently am living now. And some of them are in other provinces of China. As you know, that China is has a huge area, and including Inner Mongolia, Jiangsu province, Shanghai, and other provinces. So for currently the performance of our engineering, as you can see from here, the COD can be removed from 30% to about 80%. So this is quite a lot, especially for the non-degradable CODs. So in sum, we have done more than 20 projects right now in China, and with treatment scales from 100 to 20,000 cubic meters per day. That is a treatment scale for wastewater. And I'm happy to say that this year we have done a treatment project for the drinking water project. That is, as you know, that drinking water has more stringent or more requirements for our catalyst, as well as the it is more difficult for us to do the catalytic ozonation compared with that of catalytic in wastewater treatment. So after that, let me share an experience or example. Every time we did a market survey first and use lab scale to design our equipment as well as the catalyst. And after that, we have our first generation of catalyst. But this is not the end. We have to get feedback from our engineering side. For example, the first generation of catalyst, we found that the lifespan is not so long, several months, but it is longer than the study we did in our lab scale. And also, there is some second pollution from the first batch of the catalyst because of the erosion of the catalyst or the metal released from this catalyst. So what we did next, we did analysis as we can do in our lab scale. We use ICP, BET, XRD, XPS, or some other techniques to find the reason why the lifespan is so short and why there are some second pollutions. And we did those research in our lab scale and then manufacture the catalyst with the optimized procedure, and then have our new product, which is the second generation of our catalyst. And this one will be used in our pilot, in our engineering project again. And you can see the feedback, the research, and go to our new engineering side. This is the circle. And finally, we will have our catalyst for the wastewater treatment, aiming to remove 10 to 100 milligram per liters the COD. And I want to say that it is a closed circle from research to application, and then with the new problems, we will have to do another or more research to resolve those problems, and then we will apply those research results into our application. So it is a research to industry closed circle. And with this map, we have our 3 generations of catalyst, from the carbon-based catalyst to the second generation aluminum-based catalyst to the third generation ceramic-based catalyst. The third generation can be used in the drinking water treatment. It is like the bowl our used, so it is very clean and safe enough to be used in the potable water treatment. So another thing I want to mention is that this project is one project that is incubated or developed in this center. It is called the Environmental Technology Innovation Center of Jiande, which is also, I'm also one founder of this center. And this center, you can say, not only have the the environmental technological related things, but also the technology related with polymer, drinking water treatment, data analysis, and so on. And currently, I think for the past 7 years, we have incubated 19 companies with registered capital about 230 million yuan, which is about 30 to 40 million US dollars, and with an annual sales or annual revenue about 50 million yuan. So it is not quite large, but it is growing very fast. Every year we have our own research papers or patents with the revenue growing every year. So some tips. The first is that we should do some research related with the problem-oriented. This is our job, especially for the engineering-related majors. And second, make a research industry closed circle, and then have clear objectives and something like that. It is not only for the industrialization, but also for other work, I think. And finally, build a team with complementary advantages. And thank all of you. I have my personal email here. If you have any questions, contact with me freely. Thank you very much.
May I ask a question? I'm sorry, I keep getting everyone back on the stage. Thank you so much for sharing your fascinating story. I enjoyed it so much. I would love to ask you about your own edge. I know that China is hugely, massively competitive, and development goes really fast. How did you uniquely distinguish yourself?
Pardon?
And how did you become successful in this competitive environment? And do you are any of these companies or are your activities going global beyond China? Or
Thank you very much. Yes, as you said, that China is very huge with many competitive companies related with the water treatment. But for this technology, since we have to treat the non-biological or non-biodegradable CODs, there are very few companies have their own technologies. So the first thing is that we collaborate with big companies, and we can provide the module, which is automatic module for a certain part of the whole project, and to collaborate with them to have our product in 8. We are not going to be a competitor or be an enemy of them, but to be a friend of them. And secondly is that, as you know that some of the technologies currently is still under research, which means that most of them cannot be used in engineering projects. But this one, since we have the pilot project, and also we have a lot of data, the data from the engineering side. So we can modify the catalyst as well as the equipment, the treatment equipment very much. So we can see that we have experience to apply those new technologies in the water treatment side, especially for the ceramic catalyst. This one, I think it should be very innovative because first we need the tertiary treatment for the drinking water, and this one is safe enough to be used in the drinking water. Yeah, I hope I answer your questions. Thank you very much.
Wonderful. Thanks, Dr. Thya.
Yeah. So, thank you. Yeah.
I think we're doing good at time, right? So I can give a full-length lecture on quantum computing. Okay. So, assalamu alaikum. First of all, thank you, Lee and Vlad, and for the kind invitation, and thank you for selecting me to be part of this series. It means a lot to me to be at this stage, almost after 13 years since I attended the first WEP back in 2010. My name is Mohammed Filimban, and since this year's theme is about edge, I would like to take you through a journey over quantum leap from classical to quantum computing. I would like to give a little bit about myself. Back in 2008, I graduated with a bachelor's degree in computer engineering, and in 2009, I was lucky to join KAUST as a founding class, as a member of the founding class, and I did my master's degree in computer science, doing my thesis in the network lab with Professor Bassem Shahada. And in 2012, I joined Purdue to pursue my PhD degree. It is actually at Purdue where I met my wife, she was a KGSP student studying at Purdue at that time. I did my PhD in electrical and computer engineering, and then in 2018, I joined KFUPM as an assistant professor in the computer engineering department. Now, although my PhD was in data and information security, my interest in quantum computing actually started way back during my bachelor's and my master's degree. And I particularly remember I was strolling down in one of my favorite places in all the universities that I've been to, the library. And I was walking down with a couple of my friends, and one of them pointed out to this new book that has been acquired by the university, by the library, and the title was Quantum Information and Quantum Computing. So I remember in one of the long sleepless nights at the library, I grabbed that book and started shuffling through the pages, and I remember that I got intimidated with the symbols and formulas and kit notations, and I couldn't understand anything. And since then, my interest in quantum computing started, and I started following slides, courses, and reading articles. And fast forward, when I joined Purdue in 2013, I attended a summer school of information theory where they have invited renowned scientists in information theory and quantum information. One of them is Professor Scott Anderson, who was at MIT at that time, but he moved to University of Austin to establish a quantum computing research center. Although I missed his talk in the summer school, but I had the chance to interact with him and exchange some information about the breakthroughs in quantum computing at that time. Fast forward in 2018, I joined the computer engineering department, and I remember I was teaching a cloud computing course at that time, and it coincides with a major breakthrough in quantum computing field, which was what is called the quantum supremacy by Google. And quantum supremacy, for those, if you don't know about it, it's a term that was called when quantum computing outperforms the classical computing in any particular application. And I remember one of the students was asking me, what is quantum computing? So I spent one lecture basically explaining it in simple terms. But then I had this idea of why not giving a special topic in quantum computing in the department. And fortunately, KFUPM was and still undergoing transformation in its academic programs and research sector. And part of it is that we are no more male-only school. We admitted female students 2 years ago, both at the grad and the undergrad level. And I remember I paired up with the physics faculty, and we drafted a plan to establish somehow a program in quantum computing with different courses from physics, computer science, computer engineering, and math. Fast forward 2 years after that, the university established about 5 new interdisciplinary research centers, one of which is the Intelligent Secure Systems, which I was appointed as a founding director. And since then, we have almost about 35 plus affiliated faculty to the center, coming from 7 different departments. And this reflects the truly interdisciplinary work that we are doing and we are planning to do in the future. We have about 5 full-time researchers. We have research scientists, postdocs, lab technicians, lab engineers, and we have a number of graduate students as well. So from the title, we are focusing on building systems that are intelligent and secure, and we organize our research into four tracks: intelligent systems, secure systems, resilient cyber infrastructures, and then obviously one of the emerging topics, which is post-quantum crypto or quantum-resistant security. But since we are interdisciplinary research center, I try to convince my faculty to why not focusing on the full spectrum, on full stack of quantum computing, starting from the hardware all the way to the software. And it took me a little bit of hard time to convince them. And I always show this slide, history of computing. So computing started at the early ages of humanity with manual tools like the abacus through the manual computing. And we ended up with what is so-called digital computers, which started with the ENIAC in the 60s, and then the evolution of digital computers, where we had Shaheen 2 here at KAUST, Shaheen 1 and then Shaheen 2 here at KAUST. But at the back end, there is always this physical limitation of the progress in digital computing, and we can abstract that in what is so-called Moore's law, which states that the number of transistors per square inch area doubles every 12, 18, 24 months. And that means that we need to reduce the size of transistors. And now, we are operating at the technology of 7 nanometers. At this scale, some of the quantum phenomena started to pop up, and it basically reduced the capacity for us to go even lower. So scientists realized that, and we said we need a revolutionary computing paradigm. And probably the first question started with the great Richard Feynman, who was a physicist, in his seminal paper, Simulating Physics with Computers, back in 1980, 82 or so. In the paper, he asked 2 questions. What kind of computer are we going to use to simulate physics? And can physics be simulated by a universal computer? And this is basically started this branch of quantum computing, which is basically using some of the quantum phenomena in doing computation. So it all revolved around 3 basic principles. superposition. We all know that classical bits either take a value of 0 or 1. However, qubits, which is the equivalent bit in the quantum computing, can take a superposition or can take into any intermediate values between 0 and 1. The other principle is interference. We know that qubits, electrons, for example, can behave either as particles or waves. So we can utilize this in computation. The last principle is entanglement. And in entanglement, if we have two qubits in entangled states, that means that we cannot break it down into more fine granular states. So that means, or what that entails, if we measure one, we immediately know the state of the other, even if they are separated throughout the universe. And this phenomenon, or this principle, Einstein himself was not comfortable with, and at some point he called it spooky action at a distance. So, okay, great. We have these principles. What can it do? So the work started in the 80s, and we have a lot of progress in quantum computing, but I'm going to just show you probably the first algorithm that actually worked in very simple terminologies. Suppose that we have a set of cards, and we have actually 4 sets, 2 of which have the same color. The first 2 sets are red or black. The first set is red, the second set is black, and the other 2 sets are shuffled. One is blue. One is black and one is red. I will also call them, for sake of simplicity, I will call them constant and balanced. Now, if I draw a set and turn them on their back, and I ask you to determine whether this set is of type constant or balanced. The question is, how many draws do we need to find out whether it's constant or balanced? Now, one draw, if you think about it carefully, one draw is not enough, right? So we need at least or exactly 2 draws to check whether the cards is of a set of constant or balanced. Now, this is a very simple question, but Deutsch, a great mathematician, developed and articulated a quantum algorithm using these 2 principles, superposition, interference, that he showed that we need only 1 draw. And technically, we call it evaluation. And then we can generalize this because we are scientists, we are mathematicians. We can abstract this as in terms of functions. And he teamed up with another great scientist, Jose, to come up with another algorithm, a generalization of that algorithm, which is called Deutsch-Jose algorithm, that takes, instead of 2 to the power n minus 1 draws, we need only 1 draw or 1 evaluation. And n is the number of, let's say, cards or number of bits. And let's take, for example, 300 bits, which is a very small number of bits compared to gigabytes or terabytes that we have today. 2 to the power 300 or 2 to the power 299 is a quite large number if we know that number of atoms in the universe is about 10 to the power 80. So this is a remarkable, significant achievement for quantum computing. Now, quantum algorithm is not an easy thing to achieve. Scott Aronson himself said that it's actually choreographing a pattern of interference and amplitudes. So this is an abstract, but it's not an easy thing. And another serious algorithm that actually attracted the attention of many scientists, especially computer scientists, is what is called Shor's algorithm by Peter Shor, who won the King Faisal Prize back in 2002. And the whole purpose of this algorithm is to break down, is to actually factorize the number into 2 prime numbers. And for RSA, for cryptography, the whole algorithm of RSA is based on the computational difficulty of factorization. And if you are following the news, back about 2 to 3 weeks ago, a Chinese group actually claimed that they have an algorithm that can break the RSA key in about 300 qubits. And this was an alarming breakthrough. But then, after reading along, some of the scientists like Scott Aronson, Bruce Schneier, who's a cryptographer, there is no need to worry because probably there is some flaw in that algorithm. However, the physicist Mosca said, There is no need to panic right now. However, we should not procrastinate in our effort in migration to what is so-called quantum-safe cryptography. And so this is the projection of the number of qubits. As we are progressing, the number of qubits that are being put in systems is increasing. Just again, last month, IBM announced that we have about 400 qubits. In 2025, the projection is to have 1,000 qubits. In 2030, the projection is to have 1 million qubits. And that, for sure, will put almost all security protocols at risk. But security is not the only application of quantum computing. I'm taking this from a report by MCIT, the Ministry of Communication Information Technology, where they listed some of the potential application of quantum computing and with their projection time. So, what are we doing at KFUPM? As I mentioned, I teamed up with the faculty from physics, and we were able to establish a master's in quantum information and computing, and we had the chance to educate and interact with 20 brilliant students, one of which is sitting down in the stage. She's also a master student at KAUST. In the program, we have developed 8 courses from physics, math, computer science, computer engineering from 4 different departments. And we also developed what is a kind of concentration program for undergraduate, and we graduated about 15 students who took four courses. Now, at the center, in the Intelligent Secure Systems, we were able to form a core group of scientists who are working on quantum computing or different disciplines of quantum computing. Obviously, they're coming from physics, math, again, computer science and engineering. This is I'm just going to go over very quickly some of the research projects that they do. We have a group of faculty who's doing quantum hardware, and they were able to successfully manufacture a 2-qubit chip in collaboration with Berkeley here at KAUST. And what they're doing now is characterization and simulation of this chip. We have another group of faculty who's doing some work on topological qubits and on quantum sensing, developing an optoelectronics sensing system using perovskite. I'm just, again, I know my time is up, but I'm going to go very quickly on some of my ongoing research in quantum computing. This is one project that I work with one of the students. We have published one paper in a local conference. We wanted to investigate the use of quantum computing in machine learning. So we did one work in quantum image classification, and then we are now working on an algorithm, a quantum computing or a quantum algorithm for edge detection in in seismic images. We also did some investigatory or exploratory projects on applying quantum algorithms on what is so-called VRP, vehicle routing problem. And we wanted to take existing quantum algorithms and probably generalize it to solve more constrained time and capacity constrained vehicle routing problems. We're also working on quantum error correction, which is one of the hottest fields in quantum computing, where we wanted to employ reinforcement or use reinforcement learning for state decoding in quantum error correction code. And lastly, of course, we are working on quantum cryptography work, knowing that NIST has recently standardized one of the algorithms, Crystal Kyber, as the potentially next cryptography standard. So we are applying this into probably applying or developing more quantum resistant security protocols like private set intersection and so on. That was my time. If you want to learn more about our research in quantum computing, please visit the center's website or my personal website. Thank you so much, and I'll be happy to take any questions. Yeah, I see one. Go ahead.
Hello. So what is the next step like? Because well, as I believe like KFUPM is like the biggest organization that works on quantum computing nationally. So what is the next step that you're willing to take for our country to improve and like develop this area, like this hot area?
Thank you, Rowan, for the question. I think the next step is to expand our research group and do more collaboration with. So we don't want to reinvent the wheel in terms of research, right? So we really want to expand our group and do more collaboration with researchers from all around the world. And I'm not sure if there is any work going on at KAUST, but we'll be happy to do collaboration with KAUST and probably send some brilliant students like yourself to probably outside and transfer the knowledge back here at KFUPM. Not only KFUPM, but at Saudi Arabia in general.
Thank you.
Thank you.
Yeah, congratulations for the talk and the amazing work that you do.
Michael.
Also, having the exposure to the academic environment and teaching in the university, I realized that you must have gone through a lot of work also setting up a new study program, designing a curricula. So how was that experience for you, apart from the, let's say, very interesting research that you do?
I love teaching. Probably that's why I am surviving as an academician. But yes, I think, again, it's not only about developing the slides and so on, but it's more also interacting with the students, go back home and think about all the points that they raised and change the slides. And so it's a continuous effort. So today I have my slides. Next year I have different slides for the same topic because of this interaction with students. And yes, it sucks a lot of my time, especially from research. But I think this is as a junior faculty, this is the time where we spend and we invest a lot of our time in developing courses and learning new material and new topics as well.
Thank you.
Thank you, Michael. Thank you, guys.
So just a moment or two to wrap up what was a very enjoyable and entertaining couple of hours. One of my favorite afternoons of the year is the Alumni Lecture Series. And when I think about, and you've often heard it said that one of the biggest products, to use a word, or things that a university can do is to send graduates out into the world. And here in the Kingdom, we're sending you out to make an impact locally and globally. And I think our speakers today have exemplified that extraordinarily well. If we think about science at the edge, I think what we've seen this afternoon is that it's a multifaceted process. It's not somebody in their own lab or office by themselves, just working away. It's a social endeavor, it's an inclusive endeavor, it's having a bold vision, taking risks, and of course bringing technical expertise to the process. We've seen the whole range of that. People making an impact, providing opportunities for others, and making very significant contributions to a sustainable future. So congratulations to you all. We're thrilled at all of your accomplishments and what you're doing and the impact that you're making. And we look forward to seeing more from you and, of course, from all of your colleagues in our alumni body, both now and to come. So thanks very much. Congratulations. Now Lee is going to direct the remainder of the program. Please, Lee.
Well, to our wonderful speakers, thank you so much for showcasing what it is that you've all gone on to achieve as a result of your time at KAUST. It's been a wonderful afternoon, and whilst I was saying in my introductory remarks, there are not hordes of people within the auditorium, we do have quite the audience who are online. The joy of hybrid events. So thank you so much. I would like to now do our thank you gifts and some official photos. If I could also just acknowledge our chairperson of WEP 2023, Professor Thya, who is here and is going to help with the presentation of gifts. So if our speakers could please come up, if we could start with Seba Nadeef, and if, in fact, if you could all come up together and we'll hand out the gifts at the same time. You're all here, wonderful. And then Ahmed Al-Fadl, you don't get off lightly. We have the chairperson of the president of the Saudi Arabian alumni chapter, Ahmed, who is in the audience. So I'll be calling on you in a moment for a photo as well. Now we just have to find the gifts. Yes, yes, please, if you'd all come into the middle of the...
Step into the unknown and do something sometimes without knowing how the outcome will be.
There is nothing exciting about a safe bet or the middle of the road.
If you're not on the edge, you're taking up too much space.
Find the strength to overcome the challenges ahead.
There's an incredible human being left for you to discover once you reach the edge.
If you want to make a difference in life, be a scientist.